is solving quadratic systems. And yesterday we looked at solving quadratic systems where you take an equation, you solve it for one of the variables, and then you substitute it back into the other equation, and then you're able to solve. Okay? So the difference today is that we're just going to be looking at some word problems. Okay? So you're going to find words like sum, product, perimeter, area. You're even going to see ellipse in there. Okay, so what does sum mean to do? And product. Multiply. How do you find the perimeter of a figure? Right? 2 times the length plus 2 times the width. If it's a rectangle, basically add all sides. Okay? If it's not a rectangle. How about the area? So let's say it's a rectangle. About length times the width. And if you need the equation of an ellipse, you're going to do x minus h squared over a squared plus, remember because it's the lips, you like each other, so you're going to kiss. All right, O plus y minus k squared over b squared equals 1. So we're going to do one example problem together. It's really hard to do examples for word problems because I could do 20 of them, and then you could go in the book, and there would be one, and it would be different, right? They're all, like, sort of different. So the best thing for me to do is to get you through it and then get you working on the problems, and you get as many done in class as you can, okay? And that way, if you get stuck or you need help, I can help you. All right? So I'm going to read a problem to you, but I'm not going to make you write it down because it would take a while. So here's what it says. It says an ellipse with the center at the origin and horizontal major axis is to fit snugly inside a rectangle that it has its longer sides horizontal. The area of the rectangle is 12 square units and the perimeter is 14 units. Find an equation for the ellipse. Okay, so ultimately we're going to be talking about plugging it into the ellipse. But first, they tell us that the area is 12 square units and that the perimeter is 14 units. So we're going to use those two pieces of information. Why? Because their equations are easier up here, right? And we can use two variables like L and W or B and H, base and height, L and W, or we can even use X and Y. It doesn't technically matter what variables you use, just kind of stick with it. So for area, I'm going to use B times H, but you could use length times width. And for the perimeter, I'm going to say 2B plus 2H equals 14. So here's my two equations. Once you have your two equations, you look for the easier one. That's going to be easier to solve for one of its variables. Which one looks easier, the first one or the second one? The first one, right? So if I take BH equals 12, I can solve for either of those variables. I'm going to solve for B. That means I'm going to divide both sides by H, and I'll be left with B equals 12 over H. That 12 over H is what I'm going to plug into the other equation where the B is at. So I'm going to use substitution. And here's what that equation will look like. 2 times 12 over H plus 2H equals 14. So I just took this 12 over H, substituted in here where the B was at, and now notice that the only variable left is the H. That's the point, to only have one variable left. Okay, so now I'm going to simplify here, just multiply this by 2, and I get 24 over H, whoops, I wrote 24 over H plus 2h equals 14. And we saw this yesterday where we had a denominator, right? To get rid of the denominator, because we're dividing, we do the inverse operation, which is to multiply everything by that denominator. So I'm going to multiply all three terms by that h. So the first term, it's going to cancel it and leave us with just 24. The second term, we get 2h squared. And the last term, after that equal sign, we get 14h. Now, if I subtract that 14h from both sides, I can set this equal to 0. And if I rearrange the order, I'm going to end up with a nice little trinomial. And when your trinomial is set equal to 0, and you put it in standard order, right, or standard form, you should have your largest exponent first, your next largest, and so on, right? You want to put your exponents in descending order. Then it makes it easier to factor. Okay, whenever you're factoring, the first thing you should look for is what? GCF, and this one has a nice easy GCF of 2. So we're going to factor out a 2. That leaves us with h squared minus 7h plus 12. And then we're going to factor it to a binomial times a binomial. The square root of h squared is h and h. And then we're going to look at the 12. What two numbers are going to multiply to get positive 12? But add or subtract to get negative 7. I got negative 3 or minus 3 and minus 4, which means that the two numbers that plug in here and here are what she said, positive 3 and positive 4. Okay? So back to the original question, which was, you have an ellipse drawn inside of a rectangle, right? And and it's centered at 0, 0. So here's your center. The center is at 0, 0. The horizontal stretch is 4 units. That means how many this way and how many this way? 2 and 2. And then the vertical stretch is 3, because that was the longer one. It just tells you that in the problem. So if it's 3 units this way and this way, how much is each of these? 1.5. So 1.5, 1.5, or you could write it as 3 halves. So if you were going to write your equation for an ellipse, you would have x minus 0 squared over the a squared, which is the longer stretch is this way, so 2 squared, plus the y minus 0 squared over the 1.5 squared equals 1. And then you could just simplify it. X squared over 4, and then what's 1.5 squared? I'm sorry, I'm going to type that in my calculator. 1.5 squared. It's 2.25. So y squared over 2.25 equals 1. So this is your ellipse, the ellipse that's inside that rectangle, and that rectangle is a 4 by 3, has an area of 12 and a perimeter of 14. All right.